Hello guys, welcome back to all. Today in this video we will discuss one most important topic from chemical bonding. So that is nothing but the bond angles of some molecules. So Whisper theory. What is Whisper theory? So Whisper theory means nothing but it is valence shell electron pair repulsion theory. So this theory is proposed by the two scientists named as Sidwick and Powell. So this is very important topic. So I think it is better to write down in notes. Sidwick and Powell in the year of 1940. But later in the year 1957, it is modified, which means some modifications takes place in this theory by the another two important scientists called Gillespie and Neho. So what this theory is really explaining regarding the molecules. So in this video we are discussing today, so what is the importance of this theory and how the bond angle of the molecules will depend. So it's very important topic. So keep concentrate. We will discuss one by one. So according to this theory, so we should know what is the bond angle. He told that how the bond angle of the molecule will depend. Exactly. For example, I will tell you. In the CH4 molecule, the bond angle is 109 degree 28 minutes. So here CH4 means here one carbon atom is surrounded by the 4 hydrogen atoms. So this is CH4. Here the bond angle is 109 degree 28 minutes. And the bond angle in the ammonia NH3, it is 107 degree 48 minutes. But here also the nitrogen atom is surrounded by the 3 hydrogen atoms. Here there are total number of 4 atoms. Let me explain clearly. Here 1, 2, 3, 4. In this case the bond angle is 109 degree 28 minutes. But in this case the bond angle is 107 degree 48 minutes. Here the nitrogen atom is bonding with the 3 hydrogen atoms. And take another molecule H2O. The bond angle is 104 degree 31 minutes. H2O means oxygen atom is bonding with the 2 hydrogen atoms. Here the bond angle is 104 degree 31 minutes. If you take for example beryllium chloride, the bond angle is 180 degree. And if you take another compound BF3, the bond angle is 120 degree. How the bond angle we measure, how to calculate, and how we are saying the bond angle. So in this theory the bond angle of the molecule can be explained very clearly. Okay, let me explain one by one. So take first compound beryllium chloride. So here beryllium is forming 2 single covalent bonds with the 2 chlorine atoms. So that is why the bond angle is 180 degree, because it is in linear structure. So the bond angle is 180 degree because here the chlorine atom can contain 7 valence electrons. Here the beryllium atom is sharing 1 electron in each case because it contains 2 electrons in their outermost shell. Beryllium means it contains 2 electrons in their outermost shell. So it is sharing 2 electrons with the 2 chlorine atoms, forming bonds with the 2 chlorine atoms, beryllium chloride, and the bond angle is 180 degree and the structure is linear. Of course, Take another example, BF3. In this case, the bond angle is 120 degree. The structure is trigonal planar. How it happens means, boron trifluoride means boron is reacting with the 3 fluorine atoms, because the boron atom can contain 3 electrons in the outermost shell, so it is sharing 3 electrons with the 3 fluorine atoms. Of course, the fluorine atom can contain 7 electrons in their valence shell. So like this, the 3 covalent bonds will form, and the bond angle in between these is 120 degree, and it is trigonal planar structure. So let us see the next compound. If you take methane molecule, CH4. See here, in this case, in the first example, let me explain one more point here. In the first example here, there are 2 bond pairs are there. So this is 1, this is 2, which means 2 bond pairs are there. There are no lone pairs. Lone pairs are 0 in the first case. And if you observe in the second case, there are 3 bond pairs, because 1, 2, 3. 0 lone pairs. No lone pairs in this case. And if you see in case of methane, in this methane molecules, the carbon atom can form 4 bonds with the 4 hydrogen atoms like this. So the bond angle is 109 degree 28 minute. And the structure is tetrahedral, because it is a 3-dimensional structure. So that's why the bond angle is 109 degree 28 minutes. And if you observe in this case, here it contains 4 bond pairs, because 1, 2, 3, 4 bond pairs, and 0 lone pairs, because no lone pairs on the central atom, right? And here the carbon contains 4 electrons in their valence shell, and it will share 4 electrons to the 4 hydrogen atoms, and hydrogen contains only 1 electron. So like this, by sharing electrons, the carbon will form 4 bonds with the 4 hydrogen atoms. CH4 will form. And if you see the next example, take NH3, ammonia. Here the nitrogen atom will form 3 bonds with the 3 hydrogen atom, but here it contains 1 lone pair. So that is why the bond angle is 107 degree 48 minute instead of 109 degree 28 minutes. And the structure is also changed. It contains trigonal pyramidal structure. Why here the bond angle is changed? Because of containing 1 lone pair. Here there are 3 bond pairs and 1 lone pair. So because of that lone pair only, here the bond angle is changed. See, according to the Vespert theory, he told one important point. Because of the containing of 1 lone pair, if there are 3 bond pairs, so 1, 2, 3, 3 bond pairs and 1 lone pair. Lone pair means nothing but it contains unshared electron pair, because see here the nitrogen atom, if you observe, it contains 7 electrons, 1s2, 2s2, 2p3, which means in the outermost shell it contains 5 electrons. Among those 5 electrons, in the 2s2 orbital it contains 2 electrons, 2p3 orbitals it contains 3 electrons like this. Now here in this case only the 3 electron will participate in the bond formation. The remaining 2 electrons remains at the center of the nitrogen atom, but they are not involving in the bond formation, which means they remains at the outermost shell, but this pair of electrons are not involving in the bond formation. So that is why this pair of electrons are called lone pair. So when any molecule containing lone pair, which means unshared electron pair, so it occupies more space around the nucleus of the central atom. So that is why this central atom nitrogen, because of containing this lone pair, it occupies more space around the central of the nucleus of the central atom. The remaining 3 bond pairs come relatively closer. So here in this case, in the ammonia, the 3 hydrogen atoms comes very close to each other. But this lone pair is occupying more space. So because of this lone pair, there is a repulsion is more. Why the bond pairs are comes close together means, here because of presenting the lone pair, the repulsion between lone pair and bond pair is occurring more. So because of that repulsion, these 3 bond pairs comes very close together, and here the lone pair electron occupies more space. So due to that one, the bond angle is reduced from 109 degree 28 minute to 107 degree 48 minutes. So that is why the structure is also changed. It contains trigonal pyramidal structure. So he told that in the molecules, there is a repulsion between lone pair and lone pair is greater than lone pair and bond pair, and also greater than bond pair and bond pair, which means what it indicates that in between the 2 bond pairs there is a less repulsion. So because of that less repulsion only, here the bond pair in between the 2 bond pairs there is a less repulsion. So because of that less repulsion only, here these 3 bond pairs comes close together because there is a less repulsion. But in between the lone pair and bond pair there is a more repulsion, somewhat bond pair and bond pair. So that is why here the bond pair is somewhat more, and in between the 2 lone pairs there is a much more repulsion, which means in between the 2 lone pair of electrons there is a more repulsion when compared to lone pair bond pair and bond pair bond pair. What it exactly explains the Westward theory. So because of this repulsion only, the bond angle of the molecule will reduce. So in this case in ammonia, because of the bond angle, because of this lone pair present, the repulsion occurs. Due to that repulsion, the bond angle is changed here. And let me explain one more example. Take another water molecule. So if you observe in the water molecule, the oxygen atom can form 2 single covalent bonds with the 2 hydrogen atoms, and it contains 2 lone pair of electrons. Because see, oxygen atom atomic number is 8, contains 1s2, 2s2, 2p4 electrons. So there are total number of, which means here it contains total number of 6 electrons in the valence shell, right? But here among the 6 electrons, only 2 electrons will participate in the bond formation, which means in the 2s2 there are 2 electrons, in the 2px2, 2py1, 2pz1. Is it okay? Here in this case, in the oxygen atom, only these 2 electrons are participating with the hydrogen. The remaining 4 electrons, these 2s2 electrons and 2px1 electrons, and the remaining 4 electrons, these 2s2 and 2px2, these 4 electrons remains at the oxygen atom's center as lone pairs. Is it okay? Which means here in this case there are 2 bond pairs and 2 lone pairs. So here there are 2 lone pairs. Because of the 2 lone pairs, it occupies more space, because in between the 2 lone pairs there is a more repulsion. Is it okay? So because of this more repulsion, these 2 hydrogen atoms comes very close together like this. It occupies more space. So that is why here the bond angle is reduced to 104 degree 31 minutes. Okay, and the shape of the water molecule is V shape. The shape of the water molecule is V shape. So why it happens means, because of presenting 2 lone pairs. Actually the bond angle should be 109 degree 28 minutes in this molecule also, but it is reduced to 104 degree 31 minutes. Why it is reduced means because of presenting two lone pairs on the oxygen atom. These two lone pairs occupies more space because in between the two lone pairs there is a much more repulsion. So due to that one, here in this case the repulsion increases, so that's why the bond angle reduced, and it contains V shape or angular shape. So this is how the bond angle will change in the molecules according to the Westport theory. So the Westport theory, what he told that, let me explain once again. Let me revise all the concept. What he told that means in the 1940, the Sidgwick and Powell proposed a theory, nothing but Westport theory. Westport means a valence shell electron pair repulsion theory. And of course later it is developed by the scientist called Gillips and Nyholm in the year 1957. How the bond angle, we are discussing only one concept in the Westport theory today. How the bond angle varies from compound to compound. So here when you are observing here in the methane, the bond angle is 109 degree 28 minute. But in the case of ammonia, it is 107 degree 48 minute. In the case of water molecule, it is 104 degree 31 minutes. How it varies? So in beryllium chloride, the bond angle is 120 degree clearly because the beryllium can only form two bonds with the two chlorine atoms. It is a linear shape. In this case, there are no lone pairs, zero lone pairs. So that is why the bond angle should be 180 degree. But in the second example, so this is the first example. In the second example, BF3, boron trifluoride, here there are three bond pairs like this. Boron will form three bonds with the three fluorine atoms. There are no lone pairs. So that is why the bond angle is 120 degree and it is trigonal planar structure. In the third example, when you observe here, in the methane molecule, methane can form four bonds with the four hydrogen atoms. Here in this case, there are no lone pairs. So that is why the bond angle is 109 degree 28 minute and it is tetrahedral structure. But in the fourth case, in the ammonia, the nitrogen will form three bonds with the three hydrogen atoms, which means three bond pairs. But it is very important, the nitrogen atom will contain one lone pair. Because of this lone pair, the repulsion occurs more. So that is why the bond angle is reduced to 109 degree 28 minute to 107 degree 48 minute. And the shape is also changed, that is trigonal pyramidal shape. And the next example, what he told that, it's very important point, you should remember it. The repulsion between the lone pair is more when compared to lone pair bond pair and is more when compared to bond pair. So this is very important point you have to remember. And finally in the last example, in the water molecule, it contains two bond pairs and two lone pairs. Because of containing two lone pairs, there is a more repulsion. So that is why the bond angle is 104 degree 31 minute and bond shape of the molecule is angular or V shape. So this is what today's class, friends. And if you have any doubt, you can ask me through the comment section. And if you're watching my videos for the first time, please do subscribe my channel. And which type of videos do you want, please comment me in the comment section. And I hope this is very good explanation to you. Thank you all of you.